Hello dear students, in my previous video we have discussed a method of variation of parameter and the problems on method of variation of parameter. In this session I continue with problems on method of variation of parameter. Third problem, solve d square y by dx square plus y that is equal to secant x into tan x by the method of variation of parameter. Solution, here d square y by dx square can be written as capital D square. Here y is the common term, capital D square by dx square can be written as capital D square. Here y is the common term, take it outside. Plus here y is the common term, here the plus 1 into y that is equal to secant x into tan x. The auxiliary equation is m square plus 1 that is equal to 0. That implies m square is equal to minus 1. And take the square root on both sides. The square root of m square is m, that is equal to here plus or minus square root of minus 1. Plus or minus the square root of minus 1 is I. We already know that this is the complex number. The complementary function for this complex number is given by y is equal to c1x plus c2 sin x. Y is equal to c1 cos x plus c2 sin x, that is equal to, I take this as c1, this is y1 plus c2 y2, and y is equal to, here I replace c1 and c2 by capital A and B. Here c1 is A, capital A into cos x plus B into sin x. Call this equation 1. Here y1 is equal to c1 y1. Here y1 is equal to cos x and y2 is sin x. Next find out the y1 dash and y2 dash. Y1 dash is equal to the differentiation of cos x is minus sin x. Here y2 dash is equal to the differentiation of sin x is cos x. Next find out the Wronskian. W is equal to y1 into y2 dash minus y2 into y1 dash, that is equal to, here y1 is cos x, y2 dash is again cos x, minus here y2 is the sin x, y1 dash is minus sin x. Therefore the W is equal to cos x into cos x is the cos square x, here minus of minus plus sin x into sin x is the sin square x. Therefore sin square x plus cos square x is equal to 1. Therefore W is equal to 1. Next, A dash is equal to minus y2 into pi of x divided by W. Similarly, B dash is equal to y1 pi of x divided by W. Here A dash is equal to minus y2 is sin x minus sin x. Here pi of x is the RHS of the given equation. Therefore, secant x into tan x, that is the pi of x. Therefore, secant x into tan x divided by, here W is 1. Therefore, only we get minus sin x into secant x into tan x. B dash is equal to y1 is cos x, pi of x is the RHS of the equation, that is secant x into tan x. Here A dash is equal to minus sin x, right as it is. Secant x can be written as 1 divided by cos x. 1 divided by cos x is secant x into tan x. Therefore, A dash is equal to minus, here sin x divided by cos x. Tan x can be written as sin x divided by cos x. Therefore, A dash is equal to minus, right as it is, sin x into sin x is sin square x divided by cos x into cos x is cos square x. Next, integrate. Therefore, the integrate on both sides. The integration of A dash is equal to A, that is equal to minus integrate RHS also. Therefore, integration of sin square divided by cos square x into dx plus the integration constant k1. A is equal to minus, here sin square x can be written as, there is a relation, sin square x plus cos square x is equal to 1. Therefore, sin square x can be written as 1 minus cos square x. Therefore, sin square x is 1 minus cos square x divided by cos square x into dx plus k1. Therefore, A is equal to, here first write the positive term, multiply with minus sign, minus of minus is plus. Therefore, the integration of cos square x divided by cos square x. Here plus into minus is minus, here 1 divided by cos square x into dx plus k1. That is equal to the integration. Here sin square x divided by sin square x is 1 minus 1 divided by cos square x is secant square x into dx plus k1. That is equal to the integration of constant is the constant into x. Therefore 1 into x is x minus the integration of secant square x is tan x. The integration of secant square x is tan x plus k1. Therefore this is a. Similarly we can find out the b. Therefore b dash is equal to here cos x plus secant x into tan x. Here secant x can be written as 1 divided by cos x. Therefore cos x get cancelled, only tan x. Therefore b dash is equal to tan x. Integrate on both sides. Therefore the integration of b is the integration of b dash is b is equal to here the integration of tan x into dx plus k2. Therefore b is equal to the integration of tan x is log of secant x plus the integration constant k2. Substitute a and b in the given in equation 1 we get. Therefore y is equal to, this is the equation 1, a into cos x plus b into sin x. Therefore y is equal to a is x minus tan x plus k1 into cos x plus b is the log secant x plus k2. Therefore log secant x plus k2 into sin x. Simplify this, multiply with x into cos x minus tan x into cos x plus k1 into cos x plus again multiply with the sin x. Therefore sin x into log of secant x plus here k2 into sin x. Therefore k2 into sin x. First write this term. Therefore y is equal to k1 into cos x plus k2 into sin x. The remaining term is x into cos x. Here minus right as it is. Tan x can be written as sin x divided by cos x. Tan x can be written as sin x divided by cos x. Cos x get cancelled, only minus sin x. Then plus sin x into log of secant x. Here we neglect the minus sin x because already the term k2 into sin x is present in the solution. K2 into sin x present in the solution. Therefore we neglect this term. This term because we can take the k2 is equal to minus 1. If we take k2 is equal to minus 1, these two are same. That's why we neglect this term minus sin x, because already k2 into sin x is present in the solution. Therefore y is equal to k1 into cos x plus k2 into sin x plus here x into cos x. We neglect this term, only plus sin x into sin x plus sin x into log of secant x. Sin x into log of secant x. This is the general solution of the given differential equation. Next problem. Solve by the method of variation of parameter y double dash plus 4y that is equal to tan 2x. Therefore y double dash can be written as d square y divided by dx square plus 4 into y that is equal to tan 2x. Therefore we already know that capital D is equal to d by dx, capital D square is equal to d square divided by dx square, and here y is the common factor, take it outside. The remaining term is d square divided by dx square can be written as capital D square, plus here y is the common term, that is the outside, here only plus 4 into y that is equal to tan 2x. The auxiliary equation is m square plus 4 is equal to 0, that implies m square is equal to, shifting this term, that is minus 4, that implies take the square root on both sides. The square root of m square is m, that is equal to here plus or minus the square root of minus 4 is 2i. Therefore m is equal to plus or minus 2i. This is a complex root. Therefore the complementary function for a complex root is given by y is equal to, and here a is 0, only plus or minus I into b form. Therefore the complementary function is given by y is equal to c1 cos 2x plus c2 sin 2x, that is equal to c1 y1 plus c2 y2. I take this as y1 and this as y2, and replace c1 by a capital A and c2 by capital B. Therefore y is equal to here c1 is capital A into cos x plus c2 is b into sin 2x. Call this equation 1. Here c1 y1, here y1 is cos 2x, c2 y2, What is y2? y2 is sine 2x. Therefore, differentiate these two terms. Therefore, differentiation of y1, that is y1 dash, that is equal to the differentiation of cos 2x is minus 2 into sine 2x. Similarly, y2 dash is equal to the differentiation of sine 2x is 2 into cos 2x. Therefore, w Wronskian w is equal to y1 into y2 dash minus y2 into y1 dash. That is equal to, here y1 is cos 2x, here y2 dash is 2 into cos 2x, minus here y2 is sin 2x into y1 dash is minus 2 into sin 2x. Therefore, w is equal to, here 2 is the constant, cos x into cos 2x into cos 2x is cos square 2x. Here minus of minus is plus. Here 2 into sin 2x into sin 2x is sin square 2x. In these two terms, 2 is the common factor right outside. Here the remaining terms is cos square 2x plus sin square 2x. Therefore, w is equal to 2 into cos square 2x plus sin square 2x. This value is 1. Therefore, 1 into 2 is 2. Therefore, w is equal to 2. Next, we need to find out capital A and B. Therefore, here the formula A dash is equal to minus y2 into pi of x divided by w. B dash is equal to y1 into pi of x divided by w. Here minus y2 is sin 2x. y2 is sin 2x. Pi of x is the RHS of the given differential equation. The RHS is tan 2x. Therefore, pi of x is tan 2x divided by, here Wronskian is 2. Here b dash is equal to y1. y1 is cos 2x. Pi of x is the RHS of the given equation, that is tan 2x divided by the Wronskian is 2. Next, a dash is equal to, simplify the previous term, therefore minus, here tan 2x can be written as sin 2x divided by cos 2x. Sin 2x divided by cos 2x. Therefore, minus sin 2x into sin 2x. Therefore, sin square 2x divided by, here what is the remaining term? Minus cos 2x. Therefore, here integrate on both sides. Therefore, the integration of a dash is equal to capital A, that is equal to minus 1 by 2 right outside. Here integration, the integration of sin square 2x divided by cos 2x with respect to x, that is dx, plus the integration constant k1. Therefore, capital A is equal to minus 1 by 2. The integration, here sin square 2x can be written as, there is a relation sin square 2x plus cos square 2x, that is equal to 1. Therefore, sin square 2x can be written as 1 minus cos square 2x divided by cos 2x into dx plus k1. Therefore, capital A is equal to 1. Here multiply with minus sign. Here only plus 1 by 2. Therefore, minus minus of minus is plus. Right, first of a positive term. Minus of minus is the plus. Here the term is cos square 2x divided by cos 2x. Here cos 2x it cancel, only cos 2x plus cos 2x. Here this is minus, plus into minus is minus. Here 1 divided by cos 2x. 1 divided by cos 2x can be written as secant 2x into dx plus k1. A is equal to 1 by 2. A is equal to 1 by 2. Integrate cos 2x. The integration of cos 2x is sin 2x divided by 2. Minus the integration of secant 2x is log of secant 2x plus tan 2x divided by 2. Plus the integration constant k1. Here A is equal to multiply 1 by 2. Therefore, sin 2x divided by 2 into 2 is 4. Here plus into minus is minus. Log secant 2x plus tan 2x divided by, here 2 into 2, 4 plus k1. Here write k1 plus k1 here. That is integration constant. This is capital A. Similarly, we can find out B. Therefore, b dash is equal to y1 into pi of x divided by w. Here y1 is cos 2x. Here pi of x is the RHS of the given differential equation, that is tan 2x divided by w is 2. Therefore, b dash is equal to tan 2x can be written as cos 2x divided by, sin 2x divided by cos 2x. Sin 2x divided by cos 2x. Therefore, this cos 2x and cos 2x get cancelled. Only the remaining term is b dash is equal to sin 2x divided by 2. sin 2x divided by 2. Integrate on both sides. Therefore, the integration of b dash is a b, that is equal to, here 1 by 2 is the constant. Therefore, the integration of sin 2x into dx plus the integration constant k2. Therefore, b is equal to 1 by 2 into the integration of sin 2x is minus cos 2x divided by 2 plus k2. Therefore, b is equal to this is minus, here cos 2x divided by 2 into 2 is 4 plus the integration constant k2. Here this is the value of b. Therefore, substitute a and b in the given equation 1. In the equation 1, therefore y is equal to a into cos 2x plus b into sin 2x. Therefore, y is equal to a is sin 2x divided by 4 minus log of secant 2x plus tan 2x divided by 4 plus k1 into cos 2x plus b value is minus cos 2x divided by 4 plus k2. Therefore, minus cos 2x divided by 4 plus k2. This is b into sin 2x. And simplify this. Here first multiply with the cos 2x. Therefore, sin 2x into cos 2x divided by 4. Here plus into minus is minus. Here cos 2x into log of secant 2x plus tan 2x divided by 4 plus k1 into cos 2x. Next, multiply with the sin 2x. Therefore, here plus into minus is minus. Sin 2x into cos 2x divided by 4 plus again multiply with sin 2x. Therefore, k2 into sin 2x. Therefore, this is a positive term, this is a negative term, get cancelled. Therefore, we get k1 into cos 2x plus k2 into sin 2x minus cos 2x into log of secant 2x plus tan 2x divided by 4. Therefore, k1 cos 2x plus k2 sin 2x minus cos 2x into log of secant 2x plus tan 2x divided by 4.